boys and girls. In this lesson, we're going to learn about something really cool, ships and why they float. Have you ever wondered how these huge, heavy ships don't sink? Well, it all has to do with something called buoyancy. Let's say it together. Buoyancy. Good job. That's a big word and we're going to be saying it a lot in this lesson. So every time we say buoyancy, you say it with us, okay? Let's dive in and find out more. Look at this ship. It is big and it is heavy, but it stays on top of the water. Why do you think that happens? Well, ships float because of a special force called buoyancy. Buoyancy is the force that pushes things up in the water. When an object is in the water, it pushes water out of the way and the water pushes back. If the push-up force, buoyancy, is stronger than the weight of the object floats. Let's learn more and watch this video.
Hello again! The smart question today is, why can ships float? And the clever answer, I will tell you now. Many of you have a toy boat, and since it's light and small, you may think that's the reason why it can float. But there are also quite large boats that have many people on board. They're quite heavy and float anyway. How this works, I will show you in an experiment, and it needs the following things: a bowl of water and a piece of modeling clay. First of all, form your modeling clay into a ball. Then put it gently in the water bowl, and it sinks to the bottom. Now you take out the modeling clay and form your ball into a plate. When you let go of it, it's also going to sink to the bottom of your bowl. But if you form it into a small boat, it floats. It's not about the weight, but obviously it's about the shape of an object, whether it is floating or not. The item must displace more water to the sides as it weighs. This is called displacement. If your ship is constructed like that, it can push away more water than its own weight, and therefore it can float and doesn't sink.
Wow, boys and girls, how cool was that video? Next, we're going to do a little experiment of our own to see how buoyancy works. First, you're going to need to get a couple of balloons. I've got one here. The first balloon you're going to fill with air, okay? So grab a balloon, start filling it up. So we have a big tank of water. You can also use a big bowl if you want to. If you don't have a tank that size, that's okay too. So we're going to do a little experiment to see if a balloon filled with air floats on the water or if it sinks to the bottom. How many people think it's going to float on top of the water? Okay. How many people think it's going to sink to the bottom of the tank? Okay. And how many people have no idea but they can't wait to find out? All right. I'm super curious. So let's take our balloon together and put it right there on top of the water. Look at that. What do you see is happening? The balloon filled with air stays on top of the water. So the next thing we're going to do is we're going to get another balloon and we're going to fill it with water. All right, so the balloon filled with air stayed on top. This one filled with water, it's a little heavier. How many people think that when I put this one in the tank, it's going to sink? Raise your hand up nice and high. Okay. How many people think that when I put this balloon in the tank, it's going to sink to the bottom? Raise your hand nice and high. Very cool. How many people have no idea? All right, we're gonna find out together. Ready? I have the balloon with water, putting it in the tank. Oh, I'm gonna move these so you can see. Look, it's not staying on top of the water like the one with air. It's kind of sinking a little bit below the water. How cool is that? All right. We're going to take it one more step. I've got a balloon filled with water and some toy bananas. If you don't have toy bananas at home, that's okay. You can just use rocks or marbles or coins, whatever you have. But we have about 5 or 6 of these in this balloon with water. All right, so we're going to test it to see. We've got the balloon filled with water and bananas. We're putting it in the tank. What do you see? It goes a little bit lower in the tank than the one with water, and it goes a lot lower in the tank than the one with air. How cool is that? All right, we've got our fourth and final balloon. I've got water and I've got some marbles in this one. And the marbles are made of glass, not plastic. And glass is even heavier than plastic. So that means this balloon is even heavier than the banana balloon, okay? So last time to do a count. How many think it's gonna sink? Oh, a lot of people think it's gonna sink. How many people think it's gonna float? All right, it's time to see what happens. Are you ready? How cool is that? We discovered that the balloon filled with water and marbles, the heaviest balloon of them all, sinks all the way to the bottom of the tank. Why does that happen? Buoyancy. Well, that was really cool. We're gonna do another experiment. And for this one, you're still gonna need that same big container of water. So if you have a tank or if you have a big bowl filled with water, keep that handy. Also, we're gonna need some small objects from around the house. So if you have like a plastic bottle or maybe a rubber duck, a coin, maybe even a piece of wood from a game that you have, just whatever you have laying around the house that you think might sink or float and you wanna find out which one happens, just grab that and we'll start our next activity. So the first thing I'm gonna start with is this empty plastic bottle. Okay. What do you think is gonna happen? Do you think this bottle is gonna sink to the bottom of the tank, or do you think it's gonna stay on top of the water? Look, do you see? The bottle stays right there on top of the water because the plastic is lighter than the water, so it stays on top. How cool is that? Okay, the next one, I have this little game tile. It's like a domino piece. Let's find out together if it's going to sink or float. 1, 2, 3. Wow, it sank all the way down to the bottom. I was not expecting that to happen, were you? That's pretty cool. So that means that the tile is heavier than the water, so it's gonna sink all the way down to the bottom. Okay, this is a piece of wood. So if you have a piece of wood at home, let's see together if it's gonna sink or float. Ready? Look, I was wrong. That one stayed right on top of the water. It's just a little bit lower than the water bottle, but it's still really close to the top. Isn't that cool? Okay, this one I have a ball and it's got all sorts of holes in it and it's made of plastic, so it's pretty light. Let's find out. Ready? 3, 2, 1. Ooh, that's pretty cool. It did sink just a little bit, but a little bit less than the piece of wood. That's pretty cool. All right, the last thing we're gonna do an experiment with is this little toy turtle. I think this one is gonna float on top of the water. Let's see if I'm right or I'm wrong. Ready? 3, 2, 1. Okay, that one did stay on top of the water pretty well. It sank just a little bit, but it's pretty much gonna float. And did you see the white ball just sink all the way down to the bottom? Okay, that was a pretty cool experiment. Why do you think some objects floated while others sank? Remember, it's all about buoyancy. Objects that float have enough buoyant force pushing them up to keep them on the surface. We're gonna do another experiment. This time, you're still gonna need that tank of water. You're also gonna need some aluminum foil and some weights, okay? So I've got more of a container of marbles, and you're gonna take that aluminum foil and you're just gonna shape it kind of into a boat like this. So just kind of keep it flat and fold up the edges so that the objects that you put inside will stay when you put it on the water, okay? So once you have your aluminum boat made, we're just gonna gently put it on top of the water, and then we're gonna do a little experiment to see how many marbles or objects that you have at home it takes to sink the boat. But what we're gonna do is we're gonna put them all on one side of the boat together, okay? So let's count to see how many objects it takes to make the boat sink. All right, are you ready? I've got my first marble here. Ready? 1, 2, 3. Okay, We've got one marble and it's still floating. Let's try a second one. Okay, we've got two marbles and it still looks like it's doing good. Ready? Okay, ready? Let's do our fourth one. Okay, it looks like it's getting a little bit heavier on this side, but it's still doing real good. Let's do our fifth one. Number 6, right here. Let's see what happens. Number 7. Okay, what do you think is gonna happen? You think it's gonna sink or you think it's gonna float? It's still floating. Here's our next marble. Number 29. My goodness, is this ever gonna sink? Oh, there it went. Number 29. It took 29 marbles to sink that boat. Isn't that cool? Now we know it takes 29 marbles to sink a foil boat, or at least it took 29 marbles to sink my boat. Well, boys and girls, do you remember the last activity we just did? We took an aluminum foil boat, we put it on the water, and we put all of the marbles on one side, and it took a whole lot of marbles to make that boat sink, didn't it? It took a lot more than I thought it was. I was so surprised when we put so many marbles on one side of the boat, and it still stayed on top. Well, we're gonna do this experiment again, but we're gonna do it just a little bit differently, okay? So we're gonna keep the same boat, and we're gonna keep the same tank of water. We're gonna put the boat on top of the water just like that. But this time, we're gonna take 2 marbles, and we're gonna put 1 marble on one side and 1 marble on the other side. Why is that? Because when we have it balanced, the balance affects the buoyancy. So if we put more on one side, it's gonna tip over, but if we put more on both sides, we might have to put a lot more objects, a lot more marbles in the boat before it sinks. So let's do an experiment together to find out how many marbles it takes on both sides of the boat before it sinks. Not on one side, we're gonna do it on both sides together. So I've got 1 marble in this hand and 1 marble in this hand. So 1 and 1 makes 2. I'm gonna put 1 on the left side. I'm gonna put 1 on the right side. That's 2 marbles, okay? I've got 2 more, 1 on the left side, 1 on the right side. Now we have 4 marbles, 2 on this side, 2 on this side, okay? I've got 2 oranges, so this is gonna be 38. Ready? It's still staying. 40, oh, look at that. It took 38 marbles and, well, 36 marbles and 2 plastic orange fruit pieces to make the ship sink. How cool is that? Remember, the balance affects buoyancy. So we had more balance, so we were able to put a lot more objects on the boat before it sank because it was balanced. Well, today, boys and girls, we learned about buoyancy and how it helps ships float. We saw that objects float with a buoyant force pushing them up is stronger than their weight. We also discovered that the shape and materials of a boat affect how well it floats and how much weight it can carry. Remember, next time you see a ship or a boat, you will know the science behind why it floats. Keep exploring and discovering new things every day.